So that's the circumcenter. What's the special property of the circumcenter?
It's equidistant from the vertices?
Yes, equidistant. Okay, to the vertices. Okay, I'm going to put in parentheses. I'm going to put the points. Okay, of the triangle. All right, so those are your two big things you want to remember for circumcenter: how to make it, and what is it equidistant from, or what's a property of it. So circumcenter is made by perpendicular bisectors, that is the football construction, and it's equidistant to the vertices. Equidistant to the vertices. All right, so let's actually make one. Let's draw one here, right? So first thing we need is a triangle. So let's go ahead and draw a triangle here. And your triangle does not have to look like my triangle. Just make a triangle. You can draw yours however you want. I would use a straight edge though for sure, especially because you got one there. Okay, I'll call this triangle A, B, C. Okay. And so now I've got my triangle drawn, and we're going to do perpendicular bisectors, which means I need to now do that football construction. So I've got three sides here. I'm going to pick. You can pick any side you want to start with. So I'm going to turn my paper and start with this side of my triangle. Okay, I like to turn my paper. I like to turn my paper so that the side is facing me. If you don't mind, I mean, you don't have to turn your paper. You can just leave it right here and start doing the construction. I like to turn it though, so my paper is facing me. I think it helps me just kind of like get things, correct, or get things straight here. So I want to perpendicular bisect AC. You can kind of ignore the other two sides of the triangle when you do this. All right, so I'm focusing on AC here. Try to ignore those other two sides. Don't worry about them for right now. All right, so to do a perpendicular bisector. All right, we are going to, let's see here. Josh, where should I put the point of my compass? Since I want to do the perpendicular bisector of AC, so where should I place my compass, Josh? On A. Okay, very good. And then how far should I open up my compass?
Stop playing.
Go ahead. Okay, so it doesn't matter how far I open my compass up? Yeah, more than halfway. There we go, right? So my compass right there is more than halfway. So I'm going to do a big old swipe like that. And if your paper's sliding around on you, like Alex, if you're having some trouble with your compass, don't forget to put it on your book. Your book will help it like kind of stay put.
No, because the compass just keeps moving.
Okay, well if it's sliding around, try putting it on your book and then going from there. Okay, it might help. And then we're going to take our compass point, put it on C. For me at least, okay, on the other vertex, or on the other endpoint, I should say, and again, do a big old swipe. All right, and now we have two crisscrosses there, and you should always have two. Don't just settle for one. That's not enough. Connect those two crisscrosses, right? Okay. And so there's our first perpendicular bisector. Okay? So now we need to do another one, right? We're going to do another perpendicular bisector. So pick another side here. So let's see here. I'll turn it and let's do BC next. BC. Okay. Again, compass point on one of your vertices there. I can see my compass is not quite more than halfway, so I'm going to loosen it up some. Let it out some. So there it is, more than halfway. Again, big swipe there. And then point on B and big swipe there. Okay, they intersect on the top and the bottom there, so that's good. Try not to stab yourself with your compass. I've done it a couple times here already. Hopefully you guys are all up on your tetanus shots. Okay, so I have a problem here, don't I?
No.
Look at my perpendicular bisectors. What's the problem here?
They're not bisecting.
Yeah, they're not intersecting, so what should I do?
Make a different triangle.
No, I want to make a different triangle. What can I do to fix this?
Make it shorter.
Make it longer.
I was going to say not shorter, make it longer, right? I want to extend my perpendicular bisector. So I'm going to make my perpendicular bisector longer here. There, now they intersect. Now, let's pause real quick here. So I've done 2 perpendicular bisectors, right, for 2 of the sides of my triangle. I have a 3rd perpendicular bisector I still should do, but what do we know about all the perpendicular bisectors? They'll do what?
They'll all intersect each other.
They all intersect at the same point. So, when I do this next perpendicular bisector AB, where is it going to intersect? It's going to intersect at this point right here. So do I really need to draw that 3rd perpendicular bisector?
Maybe you just
No, we don't need to draw that 3rd perpendicular bisector. If you want to, you can. So we could go ahead and do the perpendicular bisector for AB, but it should go through where those 2 lines intersect already. If you want to save yourself some trouble, some time, okay, if you want to just kind of get things, and plus it's also a little bit less confusing because it's a little bit less construction you have to draw in there, you can stop right here if you wanted to and say, okay, there's where my circumcenter is. And in fact, I am going to stop there, okay? So there's the circumcenter. Now, you might be, what's weird about this my circumcenter here? It's outside the triangle. And you might wonder, Mr. Widmar, is that even right? Can you have a circumcenter outside the triangle? Yeah, if you need to, so you know how to take the pencil out, right? Yeah, so just take the pencil out and then sharpen it. Okay.
Moving forward, like it does this, it does the line, and
Yeah.
it just suddenly like that. It
Mm.
makes us smile.
Okay, that's weird, yeah. So so let me show you though, this circumcenter actually is okay that it's outside the triangle. Let me show you. I'm going to adjust my compass here. So again, compass point on the circumcenter now. Adjust your compass so that it just touches one of your vertices. I chose C. And if I do my circle here, look at that. It's hitting C, then it hit A, and if I circle the rest of the way around here, it hits B as well. Okay, voila. I have a nice circle that goes right around the outside of my triangle, hitting all the vertices. Okay? What do you think, anyone care to make a guess here or a conjecture about why do you think that my circumcenter here, what about my triangle resulted in my circumcenter being outside of the triangle here? Any ideas? Okay, well how, but what about the way I did it? So I mean, because the way you did it, it's inside, right? Is your circumcenter inside your triangle?
Oh, yeah.
So why is that? Why is my circumcenter in this triangle outside, maybe?
It's not equilateral.
Okay, it's not equilateral, but is yours an equilateral triangle?
Mine is
I feel like some people did equilateral triangles and theirs are still inside.
Would it work with this?
Right, so for example here, remember from yesterday, this is what we did from the notes, right? Here, this is not an equilateral triangle, right? But the circumcenter still ended up in the center, so it's not equilateral. That's not...
where the points
All right, so, well, sorry, one at a time, so go ahead,
I
ask.
think it's just where your points was connected, like, to the first 2.
Mm-hmm.
I think it's that.
Well, sure, yeah, that definitely determines it, but why, what about my triangle here, though, resulted in them intersecting outside, though? Eli, what do you want to say? Yeah. Yeah, and that's actually what it's going to turn out to be. It's because this triangle is obtuse. So an obtuse triangle results in a circumcenter outside the triangle. What does a acute triangle end up with? Inside the triangle, right? An acute triangle, the circumcenter is inside the triangle. What about then for the right triangle? Where do you think that will end up?
That's in the end.
Maybe it doesn't.
So a circumcenter is outside for an obtuse triangle. Circumcenter is inside for an acute triangle, and yes, for a right triangle, the circumcenter will be on the side. Do you drew right triangle?
Yeah.
Not exactly. That's a little bit less than 90 degrees. None of those angles are 90 degrees. That's close to 90 degrees, but not close.
How did I do it?
If you draw a precisely 90-degree angle on your triangle, if you draw an exactly right triangle, it will end up right on the triangle.
How would I do it for this?
Okay. You just pick 2 sides and draw the perpendicular bisectors. It'll work. Yours is going to end up outside because it's an obtuse triangle. All right.
measure it from here first, because if I do it like over half.
Yeah, do like
it would
BC.
go.
No, that's okay, yeah, that's okay, yeah, you can do it from there. Alright, the next special center, and this is what we're going to learn about today. Ooh, sorry, I'll move it up here, I just poked a big old hole in my paper there too. Incenter, okay, the incenter. So we have the circumcenter. Remember the word circum means to go around, right? So circumcenter is a circle that goes around the outside of the triangle. What do you guys predict the incenter will do? A circle that goes around the inside of the triangle. So if a circle goes around the outside of the triangle, it's touching all the vertices, right? It's equidistant to all the vertices. If a circle is going around the inside of a triangle, what is it touching? The sides. And so that means the incenter will be equidistant from the sides. Okay. We did not do the incenter yesterday, no. We're going to do it today, though. So it's constructed, okay, by the angle bisectors. Okay, so the incenter is constructed by the angle bisectors of the triangle. And again, like we kind of figured out there, like we talked about, it's equidistant to the sides, okay, of the triangle. Okay, so sides, vertices up here I underline, okay. So circumcenter, perpendicular bisectors, equidistant to the vertices. Incenter, angle bisectors, equidistant to the sides, which makes sense because the circle fits inside the triangle. It's touching all the sides. Okay? We're going to do one more special center. We'll learn about that one tomorrow. Okay?
Is it called the Bisector?
No. Nope. It's got a different name together. It doesn't even have the word... Well, it does have kind of the word center in it. Centroid isn't good. So for this one, I'd recommend you draw a little bit of a bigger kind of triangle here. Okay? Yeah, we'll eventually go on to the back tomorrow. So yeah, you can go ahead and draw a big old triangle here if you want to use it the rest of your room and your paper. Okay, I can't quite reach that. Got to go to my bigger straight edge. Okay, so again, draw a relatively bigger triangle than the last one we drew because all of our constructions are going to be inside this one. So something kind of big is a good idea here for this one. It just helps. Okay. And again, we'll name our triangle here. I'll call this triangle DEF. Okay, good. That could work. Yep. We'll see what happens there with the right triangle. All right. Your compass should be on your desk and not in someone's side, okay? Because you should be doing constructions right now.
Or your own side.
Right. Okay. So now we're going to pick an angle here. So I'm right-handed, so I like to pick angles over here on the right-hand side of the triangle. So I'm going to start with angle E. Okay. If you're left-handed, that means you probably have your compass in your left hand, and you'll maybe want to start over here with a different angle on your left-hand side, like this angle D here. But again, I'm right-handed, so I'm going to start over here with angle E. Okay. Now, the angle bisector, okay, it's going to go, we know it's got to go through the middle of that angle there, right, and cut this big angle E into two smaller but equal angles, right, cut it in half. So, someone raise their hand and tell me, how do we start an angle bisector construction? What do we do? All right, let's go to Gabe. Yeah, haven't heard from you yet.
So you go, or the same thing with the last one we did?
Yeah, kind of. So, so let's say I want to bisect angle E. Where should I put the point of my compass?
Halfway across the D.
No, the point of the compass. The point.
On
E, right, on point E, and then the distance doesn't matter. You can go more than halfway if you want to, or it doesn't matter. But at this point now, what should I do? We want to do an arc so that it does what? We want to hit both sides of our angle here. So do an arc so that it hits both sides of the angle. Okay, again, if you're left-handed, you're on point D or whatever, whatever you call this one, and you can do the same thing, just do an arc over here. Okay, so there's my arc. Now that creates two new little points right here, right? One right there, and one right there. Okay? And then from here, now we take our compass point and we put them on those new points. Remember that? Okay, compass point there, and swipe in. All right, compass point on the other new point, and swipe in. And look, there's X marks the spot. We're going to draw from E through that crisscross there. Okay. From point E through that crisscross there. Okay, like so. So there's an angle bisector. Again, if you want, you can like erase back some of the markings. If you're like, this is too many markings on my paper here. If it's getting too busy for you, you can erase back some of these markings here.
We should always be
Okay. Okay, something like that. All right? So now we're going to do another angle bisector. So turn your paper. Pick another angle. I'm going to do angle F here, where I've got it. Again, putting it on my right-hand side because I'm right-handed. If you're left-handed, you want to turn your paper so that you got another angle on your left-hand side there. But I'm going to pick angle F as my right-hand side here. Okay. Again, compass point. Okay, so Melissa, if I'm going to bisect angle F, where should I put my compass point to start out? On F, that's right. Okay, I'm going to adjust my compass some here just to make it a little bit different kind of markings than what I had before. And then we'll swipe to hit both sides. Okay, swipe to hit both sides, and that creates two new points. This point right here and this point right here. So I created those two new points by that one arc. Okay. Like that. And then from those points, we're going to swipe into the inside of our angle. See there, they crisscross. Okay, and notice our two angle bisectors intersect right there. So there's the incenter. We don't need to do a third one. If you want to do a third one, you can, but there's where our incenter is. Okay, where those two angle bisectors intersect, there's the incenter right there. All right, so I'll turn my paper back. Okay. And for whatever reason, this one just doesn't seem to quite work as well when we draw these circles. I don't know why, but we'll try it here. So again, compass point then on your incenter. Am I going too fast for anyone, by the way? We're all good? Okay, so compass point on the incenter there. Boom. Okay, see compass point on the incenter. And then adjust your compass so that it just barely touches one of your sides. If you see here, right now, my compass is too wide, because it's going to swing outside of my triangle. So I need to adjust it in, make it tighter. Okay, and now when I swipe my compass, it's just going to touch one side of my triangle. See that right now? It's just touching one side of my triangle. And so it should, from that measurement, if I swipe around, it should just barely touch the other three sides, so the circle fits inside the triangle. So again, you need to you probably just need to tighten up your compass some then. Okay. Of course, also the more precise you are, like it also depends on how precise you are with your angle bisector constructions too. Sometimes it will still go outside.
So the more precise, the better.
Yeah, the more care you take with making sure your constructions are good, the more likely that circle will fit inside. If you look here, mine's not that perfect either. So I do barely touch here. I do barely touch here, but I have some space between those two. I don't know if you guys can see that. There is some like error there. You can see it doesn't actually come together there. So it's not perfect, all right, but it should be close. They should be nearly touching each other because the incenter is equidistant to the sides of the triangle. Question?
I have good news, not bad. The good news, the circle's touching one side. The bad news is it's not touching one.
Okay, well, we'll get some more chances to practice here so you can, kind of hopefully get this down more. Okay, so hold on to this paper. We're going to go into the books now, okay? So if you guys would get your books out.
Should we keep the...
Yeah, keep the compass too. Yep, we're going to be using that. Okay, so books out. Let's turn to page... No, 7 is not quite right. Yeah. 372. Yeah. It doesn't what? It didn't work with the right angle? It should work still. You should be able to construct the incenter still. Okay, so again, page 372, page 372, page 372. Page 372. Let's take a look here. Okay. So, page 372, at the top of page 372, it talks about angle bisectors here. Okay, we have an angle bisector theorem. If a point is on the bisector of an angle, then it is equidistant from the sides of that angle. Okay, so here, for example, we have a ray PC, and it is the angle bisector of the big angle APB. Okay, these two distances here, from C to the one side, we call that point B, and then C to this side A, or this point on this side, point A here, these two distances here should be the same, okay, because C is on the angle bisector, so it is equidistant to the two sides of the angle. Okay? Likewise, if a point is equidistant to two sides of an angle, then it's on the angle bisector. Okay? So this kind of is really easy to apply here. So we look down here at some problems. We say, example 1 here, find each measure. So here we have LM. We want to find this length. Okay? Well, KL, if you look here, ray KM, if you see here, it's an angle bisector, right? Because you can barely see this. Maybe I'll zoom in some more there for y'all. You can see it on your paper too. Again, we're on page 372. Okay, these two angles here are congruent, right? They're marked congruent, and so therefore this KM is a bisector. So if JM is 12.8, what does ML have to be? It's got to be 12.8 as well. That's right. Okay, it's equal distance. So KLM is also 12.8. Okay. All right, next one. Okay, letter B here it says we want to find the measure of angle ABD. So here's ABD. We want to find the measure of this angle. Okay, well, since point D is equidistant from the two sides of this big angle, right? Point D is equidistant from A to C. What does that mean, ray BD? What is that? It's an angle bisector of angle ABC. Okay, we're told that angle ABC is 112 degrees. So the whole big angle here is 112 degrees. So how can we figure out the measure of this part of that big 112 degree angle there? Yeah, it's divided by 2. Yep, so it's 112 divided by 2, which is 56 degrees. So this should be 56 degrees there. Okay, it's just half of the big angle because that's an angle bisector there. Okay? Pretty straightforward there. Okay, pretty straightforward. That's it. All right, questions on that one? All Alright, let's breeze through these next two here because they're so straightforward, I think. Okay, so this next one, we want to find the length of QS. Okay, according to the picture there. So let's go to Gabe. What do you say there? What does QS's measure have to be according to this problem on the next page here? Yeah, 14.7. Got to be. That's right. Okay, SR, right, is 14.7. S is on the angle bisector here, right? You can see it's two smaller angles. And so then QS will also be 14.7. Okay, good. Shh. Guys, too much talking. Alright, number 5. Here we've got another big angle here. Looks like might be an angle bisector, and in fact K is equidistant from the two sides, right? If that's 62 and that's 62, that means K is equidistant from the two sides of that angle, so it is an angle bisector there. So KJM is 29 degrees. What's LJM? So BJ, how could I find the angle measure LJM here? If this smaller angle here is 29, how could I find LJM's measure? Not sure? Okay, so again, JK is an angle bisector of this big angle. So if the small angle here is 29, what about what this small angle's measure going to be?
29.
It's 29, same thing, 29. And so then BJ, I want to find the measure of the big angle here, LJM. So that's both of those together. So what should I do with these two 29s? Yeah, add them together. So 29 plus 29 is 58 degrees. Okay, that's just using those properties of the angle bisector. Okay, that's all there is to it. Those angle bisectors. Now, what can we do now? Well, the book wants us, we're going to practice a little more here with this inscribed circle stuff. So a circle is inscribed in a polygon if each side of the polygon is tangent to the circle. It means it touches the circle just once, okay? In the figure, circle C is inscribed in quadrilateral WXYZ. You can see how circle C fits perfectly inside that quadrilateral. And the circle is called the incircle, or inscribed circle of the quadrilateral. Okay? The center of that incircle, point C there, is the incenter, right? Incenter. So that point is equidistant to all four sides of this quadrilateral. And so now the next one here, example 2, we're going to practice this one more time, okay? Give you guys an opportunity. Some people need some more practice, right? We're going to use the compass and straight edge to construct the inscribed circle of triangle PQR. So let's go ahead and do that here. All right, so we're going to do the incenter and construct the inscribed circle. So, wow, this is good. I'll get this to you here in a second. Here, Gabe. Emergency phone delivery, phone charger delivery. There you go. Okay. Okay, so here we go. Let's take a look at this. So let's do an angle bisector. I'm going to angle bisect angle R here to start out, I think. See if I can get this to fit on my screen. There we go. Okay, so angle R. Compass point goes down on R. Try and be as precise as you can with your placement here, because that's going to help you get a nice circle, too. Swipe, so you hit both sides of that angle R of the triangle there. Swipe to hit both sides, like so. Okay. So far, so good. Swipe to hit both sides. Now, we got those 2 points we created, right? Where those swipes intersect. You can draw them, or if you don't want to draw them, you don't have to draw them. That's fine. All right, compass point goes on those 2 new points, each one at a time. Swipe in from that. If it goes outside the circle, that's okay. And swipe in from that. So they crisscross. Okay, so we'll go from R through the crisscross there. Okay, and draw right through, and there's your angle bisector. I did an okay job there. Okay, if you want, you can kind of like erase back some of your markings. We don't need to have, huge big arcs on there. You can just like erase down some things if you're concerned about like getting confused with the markings and stuff. Okay, it can be helpful to do that. Okay, like that. It kind of helps. Makes it a little more clear. Okay, and then let's pick another angle. So, let's see here. Let's go to Q. How's Q sound? So turn my book. Let me see if I can get this back on the screen here.
Should we change,
You can, I would adjust your compass too to a different measure.
does it really matter for this?
You don't necessarily have to, no, but it is, I think it's helpful. So I'm going to put my point on Q. Again, big arc to hit both sides of the angle, of angle Q. Creates 2 points. There, and there. And then I'll swipe in from those 2 new points. And connect the vertex like so. There's our incenter. Okay, so there's our incenter where those 2 angle bisectors intersect. Notice I did not bisect point P, angle P. You can if you want to. It's not necessary though. It should intersect. All 3 should intersect at that 1 point there. And just to save ourselves some time, make it a little bit easier for ourselves. Okay, we're going to do it this way. All right, so now let's see if we did it right. So compass point on that incenter. Okay, and you can see here again, my compass is way too big. Right now, if I swipe, it's going to go outside my circle, right? Like way too big. So I need to adjust it in. And this is kind of hard because it's such a small triangle. But adjust it in so that it barely touches one side. Okay, you can see how mine's like barely hitting that one side right there. So I'll circle it around. Ugh. Not good. That's okay though. Yeah, for whatever reason I don't do as well on these, but that's okay. You can see that Miss Widmeyer left some space right there. It shouldn't, right? It should be touching there, it should be touching there, and touching there too. So not exactly right, but you know, pretty close. Pretty close there for the incenter. Okay? So there that is. Questions on any of that?
If your thing doesn't touch it, does that mean you have to like measure it, carve it out or something?
No, if it doesn't touch, that just means you need to be more precise with your compass. When you're like placing your compass point down, you need to be very much more precise about where the compass point goes. That's all. More careful. And for this one, for some reason, the incenter is less forgiving than the circumcenter is. Finding the circumcenter with the perpendicular bisectors, it seems to be a lot easier than this incenter for whatever reason. I think also because it's so small. This triangle is way too small, so it doesn't really help. Okay. Okay. So let's see here. What I would like you guys to do then for some practice, okay, so I'm going to give you guys your assignment now, and I'm going to give you enough time so you can actually like do constructions here, okay? So I'm going to give you an opportunity to practice some constructions as well. So I know we need that. Okay, 1 second. Okay, so on page 375 is where your homework is going to start for tonight. Okay. I broke this up in a weird way.